Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x minus 6 to the power of x is equal to 4 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 4 to the power of x. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 4 to the power of x over 4 to the power of x. So then these two cancel out. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 1. Now, if I have something in the form a minus b over c, this can be written as a over c minus b over c. So 9 to the power of x minus 6 to the power of x over 4 to the power of x, that can be written as 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x. This is equal to 1. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 9 to the power of x over 4 to the power of x, that's going to equal 9 over 4 to the power of x. And 6 over x over 4 to the power of x, that's going to equal 6 over 4 to the power of x. Now 6 over 4, the greatest common factor of these two is 3. So 3 times 2 is 6. Or sorry, not 3. The greatest common factor is 2. 2 times 3 is 6, and 2 times 2 is 4. So 6 over 4 simplifies to 3 over 2. And we still have 9 over 4 to the power of x. Now for 9 over 4, 9 is equal to 3 squared, and 4 is equal to 2 squared. So I have 3 squared over 2 squared to the power of x minus 3 over 2 to the power of x is equal to 1. Now, remember, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 3 squared over 2 squared, that is going to equal 3 over 2 squared, and we have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And these two are interchangeable, meaning this is also equal to a to the power of n times m. So if all of this is true, then this must mean that a to the power of m to the power of n is equal to a to the power of n to the power of m. So right here we have 3 over 2 to the power of 2 to the power of x, and that is going to be equal to 3 over 2 to the power of x to the power of 2. Then we still have minus 3 over 2 to the power of x is equal to 1. Now I'm going to let 3 over 2 to the power of x equal the variable u. So now I have u squared minus u is equal to 1. And now I can subtract 1 on both sides, so I get u squared minus u is equal to, u squared minus u minus 1 is equal to 0. So now I have a quadratic equation, and I can go ahead and plug this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have, if I plug these values in, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. All of this divided by 2 times 1. Now negative of negative 1 is positive 1. So I have positive 1 plus or minus the square root of Negative 1 squared is 1, minus 4 times 1 is 4. 4 times negative 1 is negative 4. Divided by 2 times 1 is 2. This is equal to 1 plus or minus the square root of 1 plus 4 over 2. Is equal to 1 plus or minus the square root of 5 over 2. So u is equal to 1 plus or minus the square root of 5 over 2. Now remember, we set u equal to 3 over 2 to the power of x. So right here, we have, this is actually two solutions. We have 1 plus the square root of 5 over 2, and we have 1 minus the square root of 5 over 2. So let's start with 1 plus square root of 5 over 2. So I have 1 plus the square root of 5 over 2 is equal to 3 over 2 to the power of x. So what I'm first going to do is I'm going to take the log of both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus square root of 5 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would equal b times log a. So now I'm going to move this exponent x to the front of the logarithm. So now I have x times log 3 over 2 is equal to log 1 plus square root of 5 over 2. Now, I actually took, when I said log on both sides, this was to the base of 3 over 2. So if I have x times log base 3 over 2 of 3 over 2, these two will simply cancel out, and this is also base 3 over 2. And I will have x times 1 is equal to log base 3 over 2 of 1 plus the square root of 5 over 2. So now this means that x is equal to log base 3 over 2 of 1 plus square root of 5 over 2. Now, this is the same thing as x is equal to log 1 plus square root of 5 over 2 divided by log 3 over 2. And if I have something in the form log a over b, this is equal to log a minus log b. Meaning log of 1 plus square root of 5 over 2, that's going to equal log 1 plus square root of 5 minus log 2, and log 3 over 2, that's going to equal log 3 minus log 2. Now this is equal to 0.51 minus 0.301 divided by 0.4771 minus 0.307. And if you simplify this, you get x is equal to 1.868. Now we got to take a look at our second equation, which is 1 minus square root of 5 over 2. Now if 3 over 2 to the power of x is equal to 1 minus square root of 5 over 2, well, this is actually not possible because the 1 minus square root of 5, that is going to be a negative number. And you can't take the power of a positive number and make it a negative number. So meaning this has no solution, and our only solution is x equals 1.868. Alright, so in this problem, I have x to the power of x to the power of 5 is equal to 100. So, to solve this, I'm going to first start by taking the power of 5 on both sides. So I get x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, x to the power of 5 and 5, these two are interchangeable. Meaning, I can rewrite this. Well, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And a to the power of m times n, these two are interchangeable, so this is the same thing as a to the power of n times n. Well, if I have something in the form a to the power of m to the power of m, and that's equal to a to the power of m times n, this means that a to the power of n times m, that should equal a to the power of n to the power of m. So x to the power of x to the power of 5 to the power of 5, I can switch the places of these two. And now this is going to equal x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. So from here, I'm going to rewrite 100 as 10 squared. So now I get x to the power of 5 to the power of x to the power of 5 is equal to 10 squared to the power of 5. And again, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, that's going to equal 10 to the power of 2 times 5, and 2 times 5 is equal to 10. Now I'm going to let x to the power of 5 equal to the variable y. So I get y to the power of y is equal to 10 to the power of 10. If I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 10. Now remember how we let x to the power of 5 equal to y. So this means that x to the power of 5 is equal to 10. And to solve this, I'm going to take the fifth root on both sides. The fifth root of x to the power of 5 is simply x, so I'm left with x is equal to fifth root of 10.